Now, it's your favorite chemistry tutor, Fam Joe. Let's take a look at oxidation and coordination number of complex. We've been looking at complex, and I want you to ensure you are checking throughout the video to help you through your exam. Now, coordination number is also known as auxiliary valence, while oxidation number is known as principal valence. So, how do we get coordination number of a complex? It's very simple. Coordination number of a complex is the number of bonds that is formed around the central metals. When I say the central metals, I mean the transition metals. Do you remember that? So this is your transition metals. Now, the number of bonds. So most likely, we get our coordination number from the ligands. So, for example, but the only challenge is that ligands we have different type of ligand. We have monodentate ligand, bidentate, tridentate, tetradentate, and hexadentate. For monodentate ligand, what we have in monodentate ligand is that the ligands only only have one bond connected, one bond, one lone pair donated. In bidentate, they'll be having two lone pair donated. In tridentate, it will be having three lone pair, that's three bonds attached at a time. Tetradentate, four attached at a time. For example, ammonia is monodentate. H2 is monodentate, chlorine is monodentate. All those guys only, you can see that one ammonia is giving only a what? One lone pair. Another ammonia gave one lone pair. So this type of ammonia is a monodentate because at the time when they bond, they only give one lone pair. But there are some compounds, if they bond at a time, for example, ethylene diamine, anytime ethylene diamine bond at a time, instead of giving one lone pair like ammonia, it gave two. So meaning that if I have two ethylene diamine, if I have two ethylene, En means ethylene diamine. If I have two ethylene diamine, it means that there's already how many bond? How many lone pair? 4 lone pair. Why? Because ethylene diamine, they gave two, they are giving two lone pair at a time. Ammonia can only give one lone pair at a time. Can see one. So if I have 3 ethylene diamine, it will mean that that's 3 multiplied by 2, which is 6. There will be 6 bond. 3 ethylene diamine around our central atom will give us 6 bond because each of the ethylene diamine is supplying 2 lone pair. Do you get that? But in the case of ammonia, in the case of water, in the case of chloro, so if I use 1 ammonia, it means it supply 1. If I use 2, it supply, can you see? So it's as easy as that. So if somebody asks me that, what is the coordination number here? Since I know that ammonia is a monodentate ligand, and you can find more examples on this, guys. It's a monodentate ligand that supply only one lone pair at a time. So I have 6 of them. So meaning that how many bond will be around this guy? 1, 2, 3, 4, 5, 6. 6 bond. Coordination number of cobalt equals 6. One thing about coordination number is that it is fixed for every transition metal. Their coordination number is fixed. The coordination number of cobalt is 6. So now let's take a look at this one. This cobalt, this is En. En is still the same thing as ethylene diamine. En is the same thing. It's a short form of ethylene diamine. Now I told you that ethylene diamine is bidentate ligand, meaning that if ethylene diamine bond, it uses 2 bond at a time. Ammonia use 1 at a time. This guy is using 2 at a time. So if I have 3 of that guy, how many bond will be around cobalt? If I have 3 of that guy, since he's using 2 to bond at a time, and if I have 3 around cobalt, it will mean that I will have 6. So that will be 3 ethylene multiplied by how many bond at a time? 2 bonds at a time. So that will give me 6. So coordination number of cobalt here is also 6. Is that okay? Let's look at Fe. Now EDTA. EDTA is an hexadentate ligand. What's the meaning of hexadentate ligand? EDTA. EDTA is a let's take a look at it again. EDTA is a we have that guy as hexadentate ligand, meaning that if you use EDTA at a time, it's use 6 bond, it supplies, donate 6 lone pair at a time. So meaning that anytime you use EDTA, just know that there's a 6 bond around your central atom. So meaning that if somebody asks me that what is the coordination number here, I know that EDTA is hexadentate, meaning that one EDTA is using 6 bond at a time. So this guy is having the coordination number Fe is having coordination number of 6. Even though it is, you can see that it is 1 that is here. Even though this one is 3, the coordination number is 6. But when the coordination number of this guy, the number of ammonia here is 6. I said coordination is 6. En is 3 here, and I said it's still 6 because this guy used 2 bond at the time. That's 2 times 3 is 6. But ethylene, ethylene ditetracetate, ethylene diamine tetraacetate. I'll give you the full meaning of EDTA now. Now, in the case of EDTA, EDTA is hexadentate, meaning that one EDTA supply 6 bond. That makes this guy coordination number is equals 6. So coordination number is fixed, don't forget. Then another thing is we now have oxidation number. I think you should know oxidation number by now because I thought you had to go about oxidation number. Oxidation number is the oxidation number of your what do you call it, your transition metal. So here is also a coordination number. So coordination number is different from oxidation number. It's also called principal valence, and how to calculate it is the same way you calculate oxidation number. For example, if you ask me to calculate this one, I'll say cobalt NH3 6. Since it's 3 plus, then I'll equate everything to plus what? 3. So from here I'm looking for cobalt plus ammonia does not have a charge. That's 0 multiplied by 6 equals what? 3. Then from here I know that cobalt equals this is 0, cobalt equals 3. Oxidation number is plus 3 in this case. So for this one I can also look for it. So this is K3, then we have Fe, we have Cn, we have 6. Since we know that the whole of this is a coordination compound without a charge, so we say equivalence to 0. So from here we know that oxidation state of this guy is plus 1. That's 1 times 3 plus ion is what we are looking for, Fe, plus cyanide is minus 1 times 6 equals 0. From here Fe is going to be equals to plus 3. So oxidation number can change, the oxidation state can change, but coordination number do not change. So note that. So we'll be moving next to another thing about your transition metals, which is going to be colored ions, paramagnetic, diamagnetic.